So the general way of easy way of actually plotting is just by giving x and y coordinates. So first of all, let's say line has a slope of anything, and give it, you have to just remember. So if you're going to give it slope, you have to give it radians. If you want to give it tan, you can also give it tan, no problem in that. So if you actually have to give slope in tan, you're going to write tan of d. Angle, you're going to go for like 60. So m and c, you can keep anything like 10, which is the intercept. The important thing is actually defining x. X, you're going to go for like or some range. You can go for 0 to 10, and it will be like you need a space about 0 1. You can actually define new space between like 0.1. You're going to increase the spaces now. Okay, like this one. Important thing is like this. There's a number of ways to actually define x. So if it's like only 1 unit, enter it. So it's 1 unit part. How many x's are there? 11 x's. So the size is 11. So you can actually go for x also, like x2. You can include linspace in which you have to write first number, the last one, and the number of units. Then here it was 11, just write 11, run it up, the same thing happens, same output. So you can use any of the methods, and you can just mention it yourself as well. And now you're going to just write y is equal to m dot, does not, but it's only 1 unit, x size 1, mx plus c, run it up. So here are your values of y's. So you're going to plot it by using this plot of y comma x. Here is your simple way of plotting y is equal to mx plus c. So why would you need just different like spaces too much close to each other? Because you have to just plot a smooth curve. You can't just go plot a discrete value that are far apart. Like this is straight line here, it can, you can't just see it. You just can change the function of this one. You can go for like sine. Let's go for sine of x. Function of sine of x. Now plot y is equal to sine of x. Okay, now we can go for x comma y. This y comma x actually. X-axis first, x-axis, then you have to mention y-axis. Okay, second that is y. For x-axis and y-axis, this is time to look at this plot. It's not smooth. So in order to make it smooth, you have to decrease the spaces between 2 points. So how would you do that? Just include this number very small. We are going to go spaces should be now 0.1 between 2 points. It becomes smoother. So this is actually the basic way, easy way of doing the thing. So you can take it to another level to actually plot a function using mesh grid. So as I have already said what mesh grid actually means, let's do it now. Cool. Now first of all, in mesh grid you're going to refer to x comma y from mesh grid from 0 to, you can give any value 0 to 10. Okay, let's run it up. Now see how x and y looks. Look, it will be like 0 1 2. It's on x-axis as I have shown in the video. This is the y-axis, like 0 1 2, constant along axis along rows. So in order to plot y from x plus c, just write a function f is equal to x y is equal to mx plus c, y minus x is equal to 0. Just simple, this is as easy as it could be. We wrote a function. Now this function f would be 1 at the line y is equal to mx plus c. Okay, as I have said, the application of mesh grid on plotting is in image processing. So in order to see this logical f, you just have to write I am show image show f, and there is your image. Okay, this is your image. It's like downward, going downward, because in images the top left is the coordinate, the origin, and in actual Cartesian coordinate it's like the bottom left. In order to just get that thing, just have to write f is equal to, just have to flip the image. I am flip. I am flip a flip. I think flip is equal to f comma 1. So this is your image line plotting. So you can actually increase the size of image, like go for 0 to like 300. This is your image. Okay, this is your line. This application of mesh grid, as far as I know, and maybe there's more application of application of mesh grid on lines, but for me this is the main application I have done. I applied this mesh grid on. Okay, let me change slope and intercept and see how it behaves. So in order to write equation for that one, I just write m into x, and you can write minus c here, or you can write c at this point. It's up to you. Okay, let's write it like this. It's up to you now. Mx plus y is equal to mx plus c. Okay, this is the equation at 45 degree. See, let's put it 10, doesn't matter. Let's see. So this is your equation. This is intercept of 5. This is slope of 45 degree. Let's increase it 25. Okay, this is it. This is working fine. Okay, now let's say something extra. We're gonna go in next video about surface plotting and application in. We're gonna use. We won't use. I'm sure there. For surface plotting, we're going to use some isosurface or surface C. Let's see what we're going to use that time. In here, let's this is an extra. Let's draw a circle, ellipse, and image. This is extra. You don't have to follow along. So okay, what is the equation of the sphere? Not sphere, like circle is like x square. Why am I going for dot? Because I have to do square of every element, not matrix multiplication. It has to be inner product multiplication. Y dot का whole square is equal to radius का whole square. The radius is only one element, so I don't have to go for squaring of each one of that things. And r is equal to, let's say, 50. But the thing is, it would start from, I guess it's gonna start from 0. The origin is at 0, 0. So it will be like only a quarter circle will be seen, I think. Let's see. Yep, is a quarter scene, because these points are satisfying you have to go for less than inside the surface plotting, inside the surface. So this is your half surface circle. You can actually include from minus 300 to 300, because the origin is at 0, 0. This is now 0, 0 here. This is your circle. In order to actually be able to do it here, let's see here, let's change the shift the origin or shift the center of the circle. How can you do that? Equation for that is x. Just have to shift by writing x plus minus. Let's see, at first plus, then now we're going for minus. X plus 50 is not 0, x is not minus 50, so it should be minus 50. You just have to put whatever is inside is not 0 and write it down. So like we're shifting it by 50, 50. So here it is. Let's increase more. So you have shifted the origin or the center of the circle to 100, 100. This is your circle. Now if you need to plot an ellipse, in order to plot an ellipse, the equation is x square divided by a square. A is actually the major axis or minor axis, whatever you say, along x-axis. So I'm gonna go for, let's say, a and b. Let's create a variable. A is equal to along axis is equal to 100. Along b, minor axis is equal to 50. Along y-axis, you said right, a square. Here is also dot product. Dot divided by b ka whole square. R should be at 0. There is no R now. It's not needed. This is an ellipse. Wait a second, something is wrong. B square should be less than 1, not 0, 1. Yep. Okay, that's the thing. So this is your ellipse.